Hi, my name is Eric Whitkop, and today we're going to talk about securing Confluent Kafka, or sorry, Apache Kafka provided by Confluent, and we're going to secure it with Palo Alto Networks, firewalls, and technology. Now, the first issue that you're going to tackle is that Apache Kafka is proprietary binary streams over TCP 9092. Okay, so that means you're going to have a difficult time doing DLP and some other kind of, regex parsing of like ASCII text. You're not going to be able to achieve that. The best you're going to be able to achieve is to do SSL decryption and get some visibility into that traffic. And I'm going to show you today that it is possible to SSL decrypt the 9092 streams from endpoint to server. This is on GCP. I'm going to walk through my GCP settings, my firewall settings, and I'll do a quick demo. Here's the topology that we're going to be demoing today. So in GCP, we've ordered the Confluent service, which is hosted elsewhere outside of GCP, and they will make a VPC peer for you automatically. Once you've purchased, they'll provision it for you. And in this case, all my brokers are back here. These are the broker names, and I just have to route the entire 10 block. Actually, sorry, I don't have to. They provisioned 3 routes already for me. And when they VPC peered it, they created the routes for me. Okay, and in this case, it's the trust VPC, which is my trust zone of my VM series. Now, that's only because I'm coming off the internet here, and that has to be on trust, right? Then what I did is I made another zone called VPN zone, and I'm using Global Protect. I'm VPNing in over the internet, going into a trust VPC, and then hitting the Confluent on the back end. Now, if you had a direct connect or express route, whatever, back to your data center or your enterprise, then maybe the zones would be flip flopped. Doesn't matter. The point is that we're just showing that we can actually crack the packets open and get you better visibility, and we can do app ID and some other cool things. Okay. Then of course I do have Panorama, and technically the logging would come from Panorama up to Cortex Data Lake. This is a very simple demo, so don't get too wrapped up. We're just proving out the technology today. That's why we're here. So here is my GCP environment. Here are my VPCs. If we looked at my peering, you will see they built this for me. I didn't do any of this, right? But that's all built and ready to go. And you can see there's 3 routes, imported routes, and then we'll make sure those routes landed in the proper network. So if we come down here, auto-generated on the trust VPC, and that's all we needed for that. My default is still going to go to my firewall, but to get to my brokers, my Confluent brokers in the back end, I have these 3 routes here. Okay. This is the return route for my VPN to make sure that it comes back to the trusted interface of my firewall. My IP range for the VPN clients is 88, right? And then my tunnel interface is 88.8. So why don't we go over to our firewall now, and let's take a look at. I'm already VPN'd in here. Okay. Let's walk through the config a little bit, because there's certain pieces you may be interested in. Let's start with NAT. So I have to NAT. So here's one of the tricks that I figured out is that I have to NAT behind the trusted interface of the firewall so that the Confluent tenant has a route back. If I started sourcing my streams from my 88 VPN, I wouldn't have a return route back from Confluent. So what I'm doing is I'm saying, hey, when I come inbound from VPN to trust, I want you to, if the destination is all tens, hide it behind my 45.2, which is my subnet for my trust VPC. It's the 45 net. So as long as I'm sourcing from that, then the Confluent tenant will have a route back and it will work. then of course this is just to get to the internet. I'm going out the other direction. So if the destination's not a 10 address, if it's anything else, I want to go out to the internet. Okay. Security policy. I made a rule here for Confluent. Notice that I'm able to match on the application of Kafka. That's because I've been successful at decrypting that traffic. I can get in there and we can do some app ID on it. But it's important not to use application default here because we're running TLS, which is normally on 443, but this case it's in 9092. So if I were to have application default, I would break this. So my buddy Steve Boyle pointed out that we're gonna have to change that. It was a good catch. And now we're off and running. Okay, let's take a look at our decryption policy. I'm using this firewall as a CA to cut certificates. And VPN. I'm just letting you take some print screens here, right? And we're doing SSL forward proxy. I did have to push out a certificate to the VPN client, and you can do that in your portals. I pushed out I think it's agent here. I pushed out the trusted root CA. All right. Works beautifully. I'm on a Mac, by the way. And I did not do any DNS proxy. I didn't need it for this. You might need it. So if you have overlapping IPs, if you already have a 10 address inside your enterprise, you're going to need to proxy in some way. But that's outside of the scope of this demo. Go in, let's check out my static routes. Pretty straightforward. Route to Confluent, route to the internet. Okay. Can go look at my, let's see what else I could show you. These are my certs. So read the directions on how to set up SSL forward proxy. Make sure you have that working first. Quick, easy check is cnn.com. Oh, come on. cnn.com. I checked the cert. Came from my CA. It's working. We're decrypted. Okay, time for a demo. Now for testing, I'd like you to use the cloud command line that you'll download from Confluent, which appears to be a bit of a wrapper around some of the Kafka tools, but it's super easy to use. So basically you do topic create. I've already done that, and I created something called Eric test. Then you just produce and consume. So if I say, hi, does this work? It shows up on the consume side. Hi, test 2. Okay, we are working. Okay, so right now I'm SSL decrypting 9092 from my VPN remote client all the way back to the broker that's hosted by Confluent that is VPC peered behind GCP. Okay, and it works. Let's go look at our firewall. Oh, monitor, sorry. So I'm filtering on 9092. This is me, Eric, and I'm .50. And I'm not sure why that is showing up as unknown TCP, but this here is Kafka. We've been able to identify it because I was able to SSL decrypt it. Let me pull this up. There we go. Decrypted. So it is possible to decrypt it. I get the benefit of app ID, better visibility. I can even, now remember, it's a binary stream. You're not going to be able to do a lot of things. You're not going to be able, if there's a file embedded in there, it's all going to be wrapped in their proprietary binary code of some kind. Looking at malicious files, regexing strings and stuff, it really does not seem to be possible due to that limitation. There is a plugin for Wireshark from Confluent where you can actually decrypt Kafka. but it's depreciated. But, I haven't got my hands on it yet, but in the event that I can get a PCAP going, I can actually decrypt it with that decoder in Wireshark. But here's a quick, the firewall grabbed a quick packet sample, and we can see a little bit of plain text, right? I was able to get at that because we decrypted it, right? And there's one final piece that I wanted to review, and that is the decryption profile. I tried it with the default here that has a max version of TLS 1.2, and there's no MD5, and that did not work. When I made my own custom, I changed the max version to max. I added MD5 for authentication algorithm, and that was successful. So you'll have to make sure to have the proper decryption profile. And that'll do it. Thank you. And any questions, feel free to email me at ewhitcop@paloaltonetworks.com. Thank you.